Alaikum. So I'm solving this question, which is October number 13, question 6. So first, I'm going to go briefly over this question, which says a circle with center O and radius R, which means that OC is equal to R, OB and OA is equal to R as well. And then we have an arc joining B and C, and A is the center, which is like important because it just tells us that AOB is similar triangle to AOC. I mean, like they both are the same. So the area of the shaded region is equal to half the area of the circle. Okay, so the basic idea which I have used to solve this is actually divide this thing into two sectors, which is A, B, and C. So first I have found the area of A, B, C of A, B, C of the sector A, B, C, and then next plus the area of B, O, C, the area of B, O, C minus the area of B, O, C, A, because it is like repeated twice, so that's why it's subtracted. So this gives us the area of the shaded region, and which is equal to half the area of the circle. So I hope you have understood. So like I've written it in the form of the equation, which is here. Area of ABC of both the sectors BOC minus the area of BOCA is equal to area of the circle. So again, ABC and BOC minus BOCA. Okay. Next, first we're gonna find the area of BOC, or O, B, and C. O, B, and C. So first I've drawn a rough diagram over here, which is OBC. Next, and just we know the radius and all. And then in order to find this area, you have to divide this thing into two further sectors, which is AOB and AOC. So AOB and AOC, and we know that the sectors are equal. So first we're going to use AOB. We're going to focus on AOB alone here. Then we do know, in order to find the area of the sector of AOB, which is S is equal to half R squared theta, you're gonna need the theta, which is phi over here, and R, the radius, the sides. So in order to find phi, first you have to know that we are dealing with an isosceles triangle. Isosceles triangle, because these both sides are same, so that's why the angle over here will be equal to the area to the angle over there, because both the sides are equal and it's an isosceles triangle. So next we know the sum of all these angles is equal to 180, but because we are dealing with radians here, it's going to be equal to pi. So basically theta plus phi is equal to pi, which I've written over here, which gives us the value of phi is equal to pi minus 2 theta. Next we do know the angle of phi, and we do know the sides. Substituted in the area, which is half r squared theta, which gives us half r squared theta, which is phi, which is over here right there. Next we have to, now we do know the area of BOA is equal to AOC, so the area of the sector OBC will actually be twice the area of BOA. So area of the sector will be twice the area of BOA, which gives us this r squared pi minus 2 theta. Next we have to find the area of the other sector ABC, which is A, B, and C, this whole area. So which gives us, so here the area of ABC, which I have drawn over here in a rough diagram. So but here now, in order to find its area, we need to know the angle and the side, but we do not know AB. We do know the angle, which is theta. Over here is also theta, so it's actually 2 theta, but we do not know AB. So now in order to find AB, we're gonna again divide this thing, we're gonna consider two triangles, which is BOA and AOC, in order to find AB, which I have drawn over here. AOB, again we are dealing with the same isosceles triangle with the angle and these two sides and AB. So now we have to find AB. We can find this by two ways. One method is that you can just draw a line from O till here, which divides AB into two and forms a right angle triangle. You can do it by the right angle triangle method, or we can use the cosine rule. I've used cosine rule over here, which says that AB square is equal to R square plus R square minus 2 into R cos theta, the angle between these two. So I have written over here AB square is equal to this. So if solve it further, we finally get AB square is equal to 2R square 1 minus cos theta. So now now we're gonna further solve this thing. Let's solve it over here. So AB square is equal to 2R square 1 minus cos pi minus 2 theta. So now we do know it's like pi minus 2 theta, so you can just use the rule over here, cos A minus B, which gives us cos A cos B minus sin A sin B. So I've used over here cos pi cos 2 theta minus sin pi sin 2 theta. I'm sorry, it's not minus, it's actually plus over there, which finally just, well, either way it doesn't matter because sin pi is 0, and so this whole thing becomes 0, and we have cos theta, cos pi is minus 1, so it gives us minus cos 2 theta. So cos pi minus 2 theta is equal to cos minus 2 theta. So we substitute it over here, which is 1 minus cos 2 theta, which gives us 1 plus cos 2 theta. AB square is equal to 2R square 1 plus cos 2 theta. Next we have to further solve this, and we do know that the cos 2 theta is equal to 2 cos square theta minus 1. We again substitute it, and we have 1 plus 2 cos square theta minus 1. Minus 1 and minus 1 cancels out. We have 2 cos square theta, and we further solve it, we get AB square is equal to 4R square cos square theta. So taking under root on both sides gives us AB is equal to under root 4R square, which gives us finally AB is equal to 2R cos theta. So now we know the side AB, which is 2R cos theta, and we know the angle. So we're gonna substitute it in the half R square. Now here R is actually 2R cos theta, so half R square, and theta is 2 theta over here. So we further just solve it, and we finally get the area of the whole sector ABC, which is actually 4 theta R square cos square theta. Next, now we have found two things, ABC and the area of the other sector as well. Now we need to know the area of the quadrilateral BOCA, which is over here. I need to know the area of BOCA. So in order to find this area, again I've drawn BOCA over here. So now in order to find this area, again you have to divide this into two triangles where you know these both are equal, BOA and AOC. So I have drawn BOA over here. So next, now this time we are going to be using this thing, like you can draw a line from O, and I'm going to name up the point M. So we have to find this height in order to find its area, which is half base into height. So now in order to find the height, we know this is a right angle triangle. We have the hypotenuse, we have the angle, which is theta. We only need to find the height. So you can just use sine theta. Sine theta is equal to OM over R. So OM is equal to R sine theta. So the height is equal to R sine theta. Next, the area of the triangle will be BOA, which is half base into height. So base we know to R cos theta, which we have found before. So half base into height, which gives us R square cos theta sine theta. substituted over here, it gives us this. So now again we have found the area of BOA. So now we know the area of BOCA will be twice the area of BOA because these both triangles are equal. So area of BOCA will be twice the area of BOA, which gives us 2r square cos theta sine theta. Further simplifying it, area of BOCA is equal to 2r square cos theta sine theta. We do know sine theta is equal to 2 cos theta sine theta. So we're going to substitute sine 2 theta over here, which gives us area of BOCA is equal to r squared 2 sine 2 theta. So now we have found all the things, area of both the sectors ABC and BOC. We know the area of BOCA. All we have to do is equate them to the area of the circle, half the area of the circle. So we know the area of the circle is pi r square. So simply just substitute all the areas, and we finally get this. Area of ABCBOC is equal to half the area of the circle. Area of the shaded region is equal to half the area of the circle. So next I have take r square common from all these terms, and this cancels out. Next you have to multiply by 2, which gives us this. Then shift sine minus 2 sine 2 theta over there, and 2 pi minus 2 pi over there. So once we have shifted, we get this, and then we have to take 4 theta common, which gives us 2 cos theta minus 1. So again, cos 2 theta we know is 2 cos theta minus 1. So we substitute for cos 2 theta, and 4 theta goes over there. So finally we have showed it in the form cos 2 theta is equal to 2 sine 2 theta minus pi is equal to 4 theta, which is what was the question. Show that. Finally we have solved it. I do know it is a long method, but I don't know if there is any shortcuts. But this question was not that hard. I mean, like, it would take some time, but it wasn't. I didn't feel it to be that hard. Anyways, I hope I have helped, and if I did, then please do remember me in your prayers. And thank you.